Welcome to the Bug Hunters Café. Have a seat anywhere.
Thank you. Hello, Bojan.
Hello, Jason. Where's the code closet you always travel in?
I had to park it at the end of the alley and walk. She refuses to land in here today. Have you seen any paradoxes around lately?
Yeah. Look at the table over my shoulder.
Is that Alan Turing having coffee with Edgar Dextra?
Officially, I know nothing.
Talk about your legacy code. Ironic timing, actually, because I invited my friend M. Scott Ford to join us today. He's the co-founder and CEO of Corgi Bytes, which is a company that specializes in software remodeling, which is all about legacy code. They work exclusively on making existing code bases more stable, scalable, secure, rather than starting new projects from scratch. And he really loves hunting down bugs, the stranger the better, so you can bet he's seen some awe-inspiring ones. Ah, here he is now, actually. Hey, Scott, we're over here.
Hey there. How are you?
Good, have a seat.
Thanks. Thanks for letting me join you.
Scott, this is my friend Bojan.
Pleasure to meet you.
Hey, Bojan. Nice to meet you.
Can I get you anything? The coffees on Soft Terrific, they're the ones who sponsor these chats.
I'm a soda drinker, so I've got a soda that I grabbed and enjoying that right now.
Oh, cool. Yeah, I think if you need a refill later, I think we have some original 7-Up in the back fridge from the original era, too. Don't worry, it's fresh.
You need to get some anti-gravity cola. That's the best stuff ever.
I'm good with my coffee, personally.
You just can't keep it down.
Absolutely.
Oh, that's gorgeous. So,
Scott, Jason told me you're a weird person. Weird in all the good ways.
That's good to know.
I strictly don't remember saying that.
My memory is very selective. So, why the legacy code? That's like the nightmare for the most of the people I know. Myself included. Why choose that? How? Tell me.
Yeah, so I think it was really an observation of that came out of looking at all the job hopping that I did earlier in my career, and kind of trying to investigate why. Because my initial hypothesis was that I don't like consulting companies, so I need to go work for a product company. And then well, maybe I just didn't like that consulting company, so so now that I'm at this product company and I'm not enjoying it, maybe I need to go try another consulting company. And I'm at that consulting company and I'm not liking this. Maybe products are right after all, so hop to a product company. Well, I'm not liking that. So there's a lot of bouncing around, and then so eventually okay, I'll start my own business, and then I'll like that. But during the first iteration of the business model, I was coming across projects that I also wasn't enjoying, or I would enjoy them at first, but then stop enjoying them. So I was working with my business partner Andrea, and really trying to figure out why did I like these jobs at first and then not like them later, and finally made the observation that at every one of those jobs, and for a lot of the clients that I was taking on when I was doing my own business, there would be a lot of cleanup work that was needed in order to learn the system, and that investigation and discovery and learning new things. That's where I got a lot of enjoyment. And on pretty much every one of those teams I worked on, I hit this threshold or this point where I was told to stop doing that cleanup work. I was told to stop fixing bugs. I was told to stop refactoring and stop writing tests, and instead to just focus on writing features. And that's kind of when I stopped enjoying the job. And so I would, hopped over to the next one, and then they were like, "Oh, here's this brand new code base, at least brand new to you. And in order to learn it, here's the bug list. Just go fix a bunch of bugs." And so I would do that. I'm having a lot of fun doing that. And then it got pulled away. So I think just realizing that if that's what I love doing, then focus on just doing that. Find teams that genuinely want help with just that part.
That's a really amazing story. So you're basically modern day Sherlock Holmes.
Yeah, I guess, yeah, Sherlock or I don't know, like maybe uh, like a personal organizer for a code base or something like that. Like, someone you might come in to help you clean the closet or organize the
So, Dr. John Watson, and then more like. Which incidentally, does anyone remember the Dr. Watson tool that used to ship with Windows back in, somewhere around the Cretaceous era? There's a debugging tool called Dr. Watson that turned out to be very useful when Windows went kaput.
Which is often.
I don't have. I never had a lot of experience using it. I'm familiar with its name, but yeah, haven't given it a lot of try.
Yeah, I actually hadn't thought of it for like a decade until just now, and then I'm like, huh, that's right. There was a debugging tool called Dr. Watson. No, I hear what you're saying too about the enjoyment of working on legacy code, because I kind of discovered that accidentally. I didn't even realize it was a thing until I met you, actually. But I have worked on a few different open source projects, and I found that the times I was having the most fun was when I was either trying to figure out what the code was doing, especially to fix a bug, or I was otherwise, improving existing code. That was when I really enjoyed things the most. Especially, I have a particular love for memory management and debugging seg faults. I actually really enjoy the challenge of debugging seg faults. So I hadn't really realized until talking to you that was a thing, that there are menders. You've used this term before. There are makers and there are menders.
Yep. Yeah, and that was kind of born out of the idea of seeing a lot of culture that was targeted towards makers, and Make Magazine and Maker Faire and Make Fests and hacker spaces and like a hack day at a company, and there was just a lot of focus on how to creatively create things from scratch. And as someone who likes to creatively repair things or creatively restore things, I kind of felt left out, and so was trying to find what would a good counterpoint to Maker be. And so that's something Andre and I brainstormed on, and came up with the idea of Mender as someone who mends.
Can you tell me what is your start of a new project? How you get a new code base? How do you go around figuring things? Because usually when I work with code bases, we don't have any onboarding, so we just get code base and go. How would you solve that problem?
Yeah, so there's lots of challenges that you encounter when you're a code base is completely brand new to you. One is getting it to run and getting it to build. If it's a language that has a compile step, getting it to compile so you can execute it. If it's interpreted, you have similar challenges where getting the interpreter configured correctly so that you can run it, and making sure you have all the right third-party dependencies installed, identifying what those are. So for a project that hasn't done any of that documentation, if they don't have if they're not leveraging any automated tools to help them with that, such as some tool to help them manage dependencies, like in the Ruby ecosystem that we bundler, or in the Python ecosystem, there's tools that help with that too, like pipfile and whatnot. So if they're using something like that, then it helps a lot. But if they're not, then it takes a lot of investigation to figure that out. But yeah, the big challenge that you encounter on something that's completely brand new to you is, can I run this? And because if I can't run it, then it's really hard to work with. So that's that's kind of the big challenge that you have to encounter first. And on a lot of projects, like you've got other team members who are there to help you out. If it's a code base that has been completely abandoned, there's no dev team that's actually actively supporting it, then that's much more of an archaeological exercise, because you might not have, like if they had, a special computer that they were using to build it, that computer might not exist anymore. So you may have to figure out how that environment was set up, and that first challenge will kind of be, one of your hardest ones to crack in that situation.
When I'm first digging into code, I will comment a lot. Basically, I'll just kind of stream of consciousness comment through what do I think is being accomplished here. I don't consider it done until I can do that with the whole file that I'm looking at. Do you ever find that some sort of note-taking technique, whether in comments or separately, to be useful in that regard?
A little bit. I also I find myself worrying about whether or not the stuff that I'm looking at is getting used. Because I'd hate to waste the customer's money on something that we discover later is just never executed because I don't yet have enough understanding of the system. So it's one of the things I'll first try to answer is okay, this file that I'm looking at that I think is interesting and I think needs some cleanup, is there a way that I can convince myself that it's actually executed? And sometimes that's test suite can help with that, or maybe some logging that might be in there can help kind of answer that question. But really being able to figure that out, is this still used? And so that's one of the questions I really like to ask, is because I don't want to waste anybody's money cleaning up something or doing an investigation into something that could just the easiest thing to do would be delete it because it's not relevant anymore.
Yeah, from my experience, it's probably the hardest thing to do, because as engineers we always love digging into code, trying to solve the problem, and having that sort of mental fortitude to step away and just see, do I need to do this, and take a look at the business side of perspective. That's something I personally struggled a lot. How did you get to that level to actually take a look at the business side of things instead of just treating it as a code?
Yeah, I think I had this fear that the kind of cleanup work that I was asking people to let me do was being seen as a waste of money, or could potentially be seen as a waste of money anyway. Because I know there's certainly a bias against cleanup work in the software industry. On the side of the people who are paying for it, I would say there's a strong bias against it. That it's the features that are valued more than the cleanup work, and so trying to combat that with by saying that we're going to try really hard to make sure that we don't waste any of your money is really how I arrived at that. And also I think it's important to have an understanding of what the business is trying to do and where the business wants to go, and that can really inform the cleanup efforts that you're making as well. So if they have a section of the system that they're pretty sure they're going to replace within the next couple months with an outside tool, or they're going to switch to a completely different way of doing it, then that's probably not where you should start putting your efforts. Because there's you've already learned that area of the code base is kind of is scheduled to get phased out. So again, putting the energy there is not wise. So instead, put energy where it's more needed. And I think just kind of the recognition that everybody has a limited amount of money and everybody has a limited amount of time. And so how can you best make use of that?
The limited time and money thing is certainly something I've been coming up against. I'm working as a community manager for a major email client right now, and it's an interesting experience going through, because the email client is itself a fork of a previous client. It switched languages from CoffeeScript to TypeScript. It's using Electron and React and Flux, and by describing the technical details, I guarantee there's some people who are going to be able to guess what this is. But you know, nonetheless, I'm going through this, and I'm having to go through when I started, it was 1.1 thousand issues on the GitHub. Mostly because the maintainer just did not have the time or the bandwidth. He's doing this in addition to his full-time job, so he doesn't have the bandwidth to go through all of these issues constantly and keep on top of them, because that can be this huge mountain of work. And so I'm going through there and migrating it actually over to a different community or a different platform for kind of the user-facing bug reporting, so that the stuff on GitHub is more filtered. It's more focused on what we're actually doing. It's more developer centric. And in the process, then I'm having to look at all these things and evaluate what's worth the effort, because ideally we'd like to implement everything and fix everything, but there's only so much time. And I think that's something that oftentimes non-technical people in a project, whether they be the users or the project owners or management or whatever, sometimes don't realize is that we'd love to do everything, but just because one thing appears to be very easy and simple on the outside, there could be 100,000 higher priorities that you don't want to take away from fixing the critical crash just so that somebody can connect their email client to some really off-the-wall sort of email service that uses a non-standard IMAP protocol. It's like, what do you prioritize at that point? And it gets difficult, and I think a lot of people underestimate how much work actually has to go into those decisions.
Yeah, absolutely. It's that just figuring that out, like how are we going to allocate our time? Is this feature that's being requested, is it worth doing? Is this bug that's being requested to be fixed, is it worth fixing? And I think that's a challenge all the way around, because like if you're the person requesting that change, and if it's something that it's keeping you from being able to use the application or to enjoy using it, then if it doesn't get fixed, then like you have to go somewhere else. And at the same time, on the business side, if you're the only, if it's only one person that needs this, and there are, let's say there's another bug that's affecting, hundreds of thousands of people, one of those is going to take priority over the other, and it's hard, like that you have to make those trade-offs.
Yeah, I'm also wondering, how do people realize they need refactoring? Because in my experience, usually the stakeholders are non-technical person, and for them, I never got a compliment telling me, "Oh, your backend code is so beautiful." Usually, they just want to see if it works or not.
Mm-hmm.
At what point do they realize we need to actually refactor the code?
Yeah, I think for people like who are less technical and who are working kind of on the boundaries of the engineering team, and if especially if they're the ones who are making kind of financial decisions about how money gets spent, then there's some signals that will show up that will help them kind of realize that some cleanup work is needed. Because like you said, like they often can't see the way something was implemented. They can just see that it's working or not. So it has to start showing up in things that they can observe. And one of those might be how long it's taking for features to get developed, or the number of bugs that are getting reported by users. Those can be some signals that they're able to observe. And once they notice that those are kind of trending in a direction that they're not happy with, then they might start questioning, okay, why is it trending this way? And then, the answer to that variable could be, well, it's, because we've been making, the engineering team's response is often because we've been making a mess to keep up with the feature demand. And the mess we've accumulated is now slowing us down. So and they're like, oh, okay, well, let's get that mess cleaned up. So you can get back to going faster again. Or so that we can have happier customers again, because there's not tons of bugs. other factors, other signals that might show up could be, the code is so complicated or so hard to work with or so hard to understand that the company can only is only able to hire very, very senior people to work on it. That, if they hire anybody who's less junior than maybe 10 plus years of experience, then they're just not productive. And so it's like, answering why is that, and what can we do? What can we do to change that? Do we want to change that so that it's easier to hire people with less experience who can work on the system? How can we change the system to make that possible? Because the people with tons and tons of experience are more limited in number than the people with less experience.
If I understand correctly, then you're also doing the debugging of the business side of things, business logic, and finding errors there. Is that correct?
Do you mean like in terms of like the way the business itself is operating, or in then like the way that a feature's been implemented?
In the way the feature's been implemented and prioritization of the stuff. Will this be used or not? But from the business side of things.
Yeah. So like if the solution to a problem has been constructed in such a way that it's really complicated and really difficult to understand, then that could create pressures on the engineering team to need to build it. If what the business is asking to be built is very complicated, then it is very hard to put something together that's simple that would solve that. So you can often like kind of point out and say like, well, if this process were easier, then the implementation would be easier as well. Sometimes that's possible, sometimes it's not, right? There are some challenges that they're just inherently complicated and you can't simplify them. But there are some challenges that you can kind of realize that you're making it more complicated than it needs to be, or you can decide to focus on a subset of the problem instead, and you can build something simpler for that subset.
That kind of reminds me of watching the development of like Minecraft. A lot of Minecraft players have felt frustrated in the past because for a long time there it didn't seem like Minecraft was really adding much value to the product. That is, they were not adding a bunch of really interesting new features. Releases were pretty small, and the features seemed to be like largely cosmetic many times, or tweaks to the combat dynamics or whatever. And for quite some time, actually, Minecraft started focusing on some pretty technical changes that from the outside would look boring. Things like getting rid of the old system where everything in the inventory had a number, to where it all had names and namespaces. Redoing the entire command system. And they said, we only want to break this once, since everyone relies on it. But because they made those changes, then they're able to do these huge, world-altering new features, like, the Nether update, and making the oceans more alive, and, now they're working on, improving the underground experience, the cave generation. And a lot of people don't realize that was only possible because they took that time to really refactor their code from what Notch had originally created, and make it so that it could support these expansions that previously it just couldn't support.
Hi, Bug Hunters Café. Marta speaking.
Oh yes, we are open 24/7 at bughunters.cafe. You can also find us on Twitter and Dev as Bug Hunters Café. Telegram? Well, we hadn't thought about setting up any chat services for Telegraph. No, we don't have one of those. Well, we'll consider it. Thank you. Yes, goodbye. I have never been told to get in the 19th century before.
So, Scott, another thing that I wanted to ask you is testing. How do you start testing something that's so strange and alien like the legacy code? Usually I start with just a single test, basically end-to-end test to see, okay, this thing is working, and now I'm going to try changing something or getting deeper into it, and I want to make sure nothing burns down.
Yeah, I think that's an important first step is like the one you just outlined is like having some kind of initial test to make sure that like nothing's, like you said, nothing's burned down or nothing's burning. I'll often call that like just like a smoke test. Like, does it build? Does it run? Can I do something simple without it crashing? Because usually on most systems, you're actually exercising a lot just to even get that answer. Like if you're just starting the application up, doing something simple like logging in, and then closing it down, you're exercising a lot of things that have to be working correctly in order to do that. So I think that's an excellent kind of smoke test to have. And then I like when I'm gonna make a change or like I see a change that I want to make, I do like to try at least to follow test-driven development and find a way to specify a failing test. For whatever it is, the change that I want to make it, wherever it's easiest to write that. So sometimes that's like a failing acceptance test, kind of like acting like a user, so kind of driving the user interface. Sometimes it's kind of working really low level and small in the code, so like just calling the function that I want to make a change to, calling that inside of a test fixture. And that can vary, and it's usually like, especially when I'm working with a new project, it's what's going to be the easiest test to write to get the answer to the question of, have I not broken anything, and have I introduced the change that I want to introduce?
Do you ever find yourself having to refactor tests in a code base, then like tests that were there before you got there, and you have to wind up rewriting them?
Sometimes, and like there's a technique that I like to follow that I learned from reading a blog by Michael Feathers, and he credits Liz. I don't know how to pronounce her last name. It's Keogh, I think. Q. I think it's Irish, so like the pronunciation of it is not something I'm great with. But the technique is to force the test to fail. So if you have a test that you think you want to make some changes to, you almost have to do the reverse of what you would do when you're doing TDD. So in TDD, or typical TDD, when you're testing a feature that you want to make a change to, you first create a failing test, and then you make the change that you want to make to the code under test, and then that changes, and then you can observe the test now passing. So the test was failing, then you made your change, and now the test is passing. But when you find yourself wanting to refactor or clean up a test itself, there's risk in you making it so that the test doesn't test what it tested before. That's really, it's a mouthful. But you can basically turn it into a false positive test, right? So you can turn it into a test that will now always pass, or no longer tests the thing that it used to. So what you can do to guard against that is to look at the code that it's testing, and then introduce a change that will cause the test that you want to work on, that will cause that test to fail. And so you're able to observe the test passing, then you're able to introduce a mutation and observe it failing. Then you can start refactoring the test, and while you're refactoring it, it should continue to fail. So whereas when you're typically refactoring production code, you're wanting to make sure the test continues to pass. In this case, you want to make sure that the test that you're refactoring continues to fail. And then when you think you're done, you can then revert the mutation that you added, and you should observe the test going from failing to passing. And if that doesn't work out cleanly, then you did something wrong in your refactoring. Your refactoring altered the behavior of the test.
That makes a lot of sense. You were describing that. I was thinking about there are also times where I'll have my interns write tests that are intended to, they only pass because they're failing. If that makes any sense, it's like like not only do I test for what should be there, but I also ensure that it does not do what should not, or what it should not, or that while 2 + 2 is 4, that 2 - 2 is not also 4. Have those kind of aversive tests, but thinking it through, then even if one already uses that technique, which of course I strongly recommend myself, having, those inversive tests. What you described still makes sense even in that context, because just because this other test is failing where it should fail does not mean that the test you're refactoring is safe from being a false positive.
Mm-hmm. Yeah, and you may discover when you start, like if you follow that process, one of the problems you can run into is you're not able to make the test fail. Like you may think it's testing the thing that you think it's testing, but then and you see it passing, but then you go and introduce a mutation that should make it fail, and if it's still passing, then that's a head scratcher. It's already a false positive, and that's important to know. So you could either figure out why it's a false positive, get it to fail, get it to a failing state first, and then you can proceed from there.
This is actually quite brilliant, because I never thought about refactoring the code that is failing the tests. But in the hindsight, it makes quite a lot of sense.
Yeah, I view test code as it's still code, and I know there are some teams that have different standards of quality for the code that they use to write automated tests and for the code that they use to execute in production. And kind of the opinion that I work from is that it's all code, and so we should have the same standards for it. So if we have cleanliness or quality standards for production code, then we should really ask ourselves, or really challenge ourselves, why aren't we following those same cleanliness and quality standards for the code that's running automated tests? One area where I've seen some teams differentiate between the two, and it's a way that I do think makes sense, is to allow more duplication in the test code than in the production code, especially if the duplication in the test code is helping with readability of an individual test. If it's helping with understanding of an individual test, then I think that's one area. But kind of allowing a test to be really, really complicated, or have horrible variable names or horrible indentation, or but hey, it passes. I think it's important to still kind of look at the quality of the code that's running the automated tests.
It's right to have wet tests and dry code, but it's not okay to have spaghetti tests.
Yeah.
I completely agree. From my experience, when the test code is bad, usually what happens is when there are new changes, a team will just add skip to those tests and continue working on the feature. Basically, yep. We don't have time and our energy to refactor our tests as well, or to make changes to them. So for me, making a readable test is pretty high on the priority list.
Mm-hmm.
Well, and I have a default thinking that if a test isn't readable, I'd be concerned. If any code is not readable, I'm immediately concerned as to the logical soundness of that same code, because usually when you get unreadable code, you wind up in a lot of situations where the programmer was either A, in a hurry, or B, trying to be clever, and both of those things are mutually exclusive to well thought out design.
Yes and no. I mean, sometimes the cleverness is to help solve another problem, right? So sometimes the cleverness is to help with performance, and so one technique that used to show up before compiler optimizers were sophisticated enough was that it was faster to do a bit shift left 1 bit. That was fast. That was a faster operation than multiply by 2. It was mathematically equivalent, and eventually optimizers would see if you were taking an integer and multiplying it by 2, the code that gets generated, the assembly code that gets generated, is just to do a bit shift to execute that, because that's the fastest way for the processor to do it. But if you had a compiler that's not optimizing in that way, and that's an operation that's expensive, or maybe it's happening a lot, having going from something that the compiler that the processor does in 2 clock cycles versus something the processor does in 1 clock cycle can have a huge impact on performance. And when you're reading it as somebody who's working on the project, you'd be like, you may look at it and think, oh, that person was being too clever. But they may have actually had a really good reason for doing it that way, and it may have been to solve another problem.
Sure, yeah. Although I would say at that point, you should probably stick a comment on it somewhere in the process. Although obviously not if it happens a lot in like those little tiny ones. I think when I say clever, I'm more referring to the larger, a larger section of code that is written in a really convoluted fashion without any attached explanation thereof.
Gotcha.
Like the people who write Python code that's it's a nested generator expression that all crams onto 2 lines. And in reality, it doesn't actually do anything more complicated than just a regular loop. But they did it that way because, let's face it, generator expressions in Python are really, really addictive. You feel smart writing them. I enjoy code golfing for that exact reason. But if you trip over it in production code, then you really kind of have to wonder, well, is this sound logic? Because it's a pain in the butt to debug. But then you also have to wonder, all right, so since the selection of tools is not being fit to the problem, but being fit to what looks cool, then there's some question about the reliability of that code at that point, I think.
Yeah. Also, what I usually tend to encounter is when developer is learning the language, they start using some esoteric parts of the language that are not well known. For example, meta classes, or start doing some weird stuff with decorators, because when they start learning Python, that's, we can do this stuff that we can't do in our previous language. So for me, that is a pretty big challenge to see, okay, how can I dumb this down so everybody can understand it and read it? And is this cleverness necessary, or is it not? Because usually with meta classes, I almost always find them not as good as any other alternative.
Yeah, and I think like that also shows up with I almost feel like in software there's a lot that's really fashion. You have different approaches that are fashionable, and you have sometimes those approaches will fall out of fashion. I know that when I first discovered the object-oriented design patterns book, I really liked the singleton pattern. I thought it was really fantastic, and I instantly saw many places where I could use it, and so I kind of started using it everywhere. Like it was the hammer that I used for every nail, whether it was a nail or not. And so I think it's like kind of like just recognizing that when I come across code that might be overusing a particular pattern, it could be that person was so used to thinking in that pattern because it was kind of fashionable for them at the time. That's why it was done that way.
Yeah.
That big old question of why. Why are we doing it this way? Why this and not that? I was having a conversation with someone about that mail client I've been working on, and I mentioned that it was using Flux. He said, well, isn't Flux out of date? It's getting a bit long in the tooth. I said, who cares? It works. And if it does what it needs to do, and it produces, maintainable code, then, it really doesn't matter too much, if at all, until you start actually having things like maintainability concerns or performance concerns creep in. But at this point, none of that is a factor in what this mail client is doing. I think we do tend to choose languages and patterns and techniques and whatnot based on popularity, and really should be, like you're saying, Scott, the suitability. Is this the best tool for the job? And maybe that's sometimes why people shy away from legacy code, because, well, it was using the not so fashionable patterns and languages, and who wants something that uses PHP? It's like, well, fact is, PHP is still an active, maintained, and very useful language. And there's nothing wrong with it. If you can work with it and get good results, who cares?
And that's true for almost any language you can name at this point. Like there is a community of people who are still passionate about that language, and there are organizations that are still, putting money into trying to make that language better and try to serve that the community of people who are built up around it. So I think that's true for just about anything. I do think that like certain language communities where there is a lot of change and there's a lot of rapid change, then a stigma starts to develop that if something is old, then it's bad because there is so much change. And I think you get used to new things being good because it's the things that are being introduced to solve problems that we were encountering recently. Those are the ones that everybody wants to gravitate towards, and so it's you kind of trying to keep up with that change in those communities. It can be really challenging.
Yeah.
Yeah, I also think that in tutorials there is one important stuff that's almost always missing. That's when not to use this solution. Almost always how to do this, but almost never there is a part. Don't do this under this and this and this situations, because usually you get a limitation. Okay, this I have a knowledge limitation, and once you solve that knowledge limitation, you don't actually learn a domain limitation of the tool you're going to use.
Right. Well, that's why I like Game Programming Patterns by Robert Nystrom. It's an excellent book, and he goes into all of those object-oriented design patterns. Whether you're building games or not, that's a good book to read. And he spends a significant portion of the text talking about when not to use each of the design patterns.
That's amazing. I'm gonna have to add it to my reading list.
Yeah, I think another patterns book that includes a lot of really good discussion about when to use a particular pattern and when not to is the patterns of enterprise applications. That was written by Martin Fowler. It's the book is a little old, but it's like just because it's old, I don't dismiss it. Like it's still really really good. And one of the things
I learned microservices from that book.
Yeah, and so like in one of the classes of patterns that it looks at is like how to store data in a data store, and it looks at like 3 very different ways of constructing your code to do that, and it talks about the trade-offs between them. When would you start with one versus when would you start with another? It even kind of calls out how difficult it's going to be to switch from one to the other. So I think that's another book that has really good discussion about those factors, and it does that for other patterns in the book as well. But the discussion around the different ways to store, the different patterns to follow when storing data really stand out to me. So like it looked at active record, it looked at data mapper, it looked at data table gateway, and kind of explored those 3 approaches and when does it make sense to use each one? How hard is it going to be to move between them? Which one is the most versatile? And kind of like when will a particular pattern become difficult to work with?
You mentioned too just a moment ago that even though it's an old book, it's still a good book because it shouldn't be dismissed. I think that's true of a lot of things. I believe it was author C.S. Lewis who referred to chronological snobbery, where we think, well, now we have the answers. Now we understand how everything works. And so, we understand things and those people back then didn't get it. And oftentimes we wind up losing knowledge. I think that's one of the other things that attracts me to legacy code is that there are things that the programmers who came before us understood. There's things that they knew. Like, until this conversation, I didn't really think about the fact that a bit shift could be, at least from an assembly perspective, a faster operation than multiplying by 2, but it makes sense. Little things like that, and sometimes huge things that, our predecessors understood that we lost largely because of the abstractions that we have that just make everything so magical to where, you can create a dynamically allocated array and never even once think about, memory allocation. But that comes with a hidden danger in that we start misusing patterns because we have no idea what's happening under the hood. And, you know, I've mentioned this before, Google Chrome uses more memory to load a single web page than it took to run the entire Apollo mission.
Yeah, I mean, that's certainly fair. I think you could almost also argue that that single web page is more complex than the software in the Apollo. Like, you know, so like the memory demands I think would be higher. So I don't know if that's a fair comparison. I do hear the concern and the critique often about relying too much on abstractions without having a good understanding of what's going on underneath the abstraction. And I feel like that's an argument that you can have at pretty much any level of abstraction. You know, pretty much every abstraction relies on another abstraction. And when you're working at a particular level, having some understanding of the level below where you're working at is useful. But I worry about that argument then getting extended to say that you shouldn't work at a higher level of abstraction. You should only work at lower levels of abstraction. Or like you should be an expert at the lower level down. Because I don't know that that's necessarily always true or always useful. And I worry that can become like a way to kind of gatekeep inside of a community. It's like, oh, well, you don't know what's going on underneath the covers, so you don't really belong here. And like I definitely wouldn't want the communities that we work in to have that attitude. Like, I think we won't grow and we won't thrive if we do.
Well, the way I usually put it is just that abstractions are there to save us typing rather than thinking. You know, if we can at least kind of have this, at least, you know, conceptual understanding of what it is that's happening. And that's something you develop over time, obviously. Mm-hmm. But as long as one aspires to have that conceptual understanding of what's underneath the abstraction, there's nothing wrong with the abstraction. But it's just important to know where the trade-offs are, because, you know, like there was one developer who, you know, on a comment board somewhere said, well, who even needs to understand, you know, mathematics, and, you know, in terms of how the computer thinks about mathematics, you know, that our grandfathers figured that out, you know, we just let the computer do it, you know, for us, and we don't care. And it's like, well, no, we should care, because as soon as you start working with floating point integers, it becomes extremely relevant what's going on at the CPU level.
Oh, I love teaching junior developers about that. Basically, make a for loop that adds 0.1 10 times and evaluate if it's equal to 1. That blows their minds when they see that.
Yeah. I once saw a T-shirt. Gosh, this is probably over 20 years ago. But it was like Intel, where quality is job 0.99999. Was the joke. Based on that observation, you write something out like in logical pseudocode that should result in 1. Like the answer should be 1, but because of the way floating point arithmetic is implemented, you don't get exactly 1.
Yeah, which gets really scary when you start working with JavaScript and you realize they don't have integers. I mean, well, asterisk, some of the engines do. Some of the engines actually do indeed implement integers. But the fact that the language doesn't specify it can lead to some pretty scary things. You know, and again, you would not realize that could be a problem unless you understood that JavaScript doesn't have an integer type, according to the language spec. And you really need to understand whether your engine has integers or not. Otherwise, you can wind up relying on math that is implicitly unreliable. But of course, this goes hand in hand with, you know, the other thing I'm, you know, often saying, which is the best time to learn something is when you need it, because we can't know everything. So it's like, you don't have to memorize the abstractions now. This is not, you know, me saying, you know, go learn assembly, you're not a real coder. But if you find yourself working with, say, a sorting algorithm on a regular basis, you probably should find out how sorting algorithms work, because it's really going to matter. Right.
Yeah, and I feel like you can, even once you're working with, so you know assembly, but in order to know assembly really well, you have to know what the processor's doing. In order to like really know what the processor's doing, you have to know microelectronics. And in order to really know microelectronics, you have to have a really good understanding of electrical physics. And to have a really good understanding of electrical physics, you have to have a really good understanding of quantum physics.
Incidentally, we have a yak out back that needs some shaving if you have some time.
Right? And so, like, at what point, so like the joke I'll often make is when I hear somebody saying like, "Oh, we shouldn't be using JavaScript anymore. We should be working at the lowest level possible." And I'll say, "All right, I'll go get a magnetized wire, and we can go program the computer that way."
Yeah, real programmers use butterflies.
To just try to be super hyperbolic and just say like that argument taken to its extreme logical conclusion is absurd.
Yeah, exactly. This turtles all the way down.
Yeah.
we need to know abstractions, but we need to know them as they're needed. This is like on demand learning, not which most beginners, including myself when I first started out, walk in with the starry eyes and go like, "I'm going to learn everything," and it's never going to happen.
Well, I think also like when you're first new to anything, the size of everything is a lot smaller than you realize it is later. If that makes any sense. Like you don't yet know what you don't know, so the universe seems smaller than it does later on, and you kind of look back at how big you thought things were, and then how big you realize they are now, and yeah, so it's kind of, I don't know. I feel like I have empathy, and I can understand that desire, like oh, everything is learnable because it doesn't seem that complicated. Well, just because I haven't dug into it deep enough and haven't found the complexities yet.
Yeah, anything is learnable, but not everything, which is actually why I do think it would be beneficial, for many, perhaps not all, but many young coders to pick up something like C, some other low-level language, at some point early on in their career, even just to play with it a bit. Because just cracking the lid on the the inner workings of programming languages, you spend 30 minutes in C and you really quickly understand just how little you actually understand.
Oh. Yeah, and I would worry about somebody who's already grappling with imposter syndrome.
Yeah.
Hearing that and then feeling like now they have to go do that in order to feel like they're a real programmer. That could be hard to hear.
Sure. Yeah. Well, and it's kind of funny because we all wind up feeling like that sometimes. It's like, well, I'm not a real programmer until I can do this. Like, no, you can. That really does have to go hand in hand with you. You're a real programmer if you've ever told the computer to do something and it did it. You wrote some code and it did something. You're a real
even
programmer.
If it didn't. Like more often if it didn't. That's where I spend most of my time. It's not doing what I wanted.
Yeah.
Actually, the thing that I hate the most is when it works, but I don't know why it works because it should fail.
I actually had to add a spooky tag to the bug tracker I'm working on right now for that exact purpose. It's like we don't know what this is doing, why this is here. We're not even completely sure it's fixed, so it's just spooky.
It's just not happening anymore.
Yeah. It's interesting the tightrope that one walks as a developer, because on one side is the pit of the pit of imposter syndrome, and on the other side is, I believe you were the one I learned this from, the mountain of stupidity. Was that you who I learned that from, Scott?
I don't know. It doesn't sound familiar to me. If I said it,
It may have been someone else then, but someone mentioned that you have, on one hand you have the pit of imposter syndrome, on the other side you have the mountain of stupidity. The mountain of stupidity, when you're at the top, you're like, I know everything, I can do this. There's nothing I cannot do. This is easy. I don't need any help. And in reality, you don't have a clue what you're at. And and then on the other side is like, I don't know anything, I can't do anything, and then you're paralyzed. It's like you don't want to be in either place.
Right. Yeah, and I think a lot of the work is getting used to the not knowing, and I think that's something that I find is really challenging for people who are new to programming in general. Is I don't know why this works, and kind of learning to be okay with that. Because again, I think it's like how far deep down the level of abstraction are you going to go to the answer to what's actually going on, or is it? Do you need to do that discovery process, or is it enough to just remember that works?
Yeah.
And maybe one day you'll learn a better way, or maybe one day you'll learn why it works, or how to maybe even manipulate it to make it work differently. But do you need to know that right now, or is it good enough and can you move on?
Yeah. It's I guess it's just the attitude of I don't know why it works, but I can find out if I need to.
Mm-hmm. Yeah, and I think like everything is like. I do feel like in computing everything is learnable, but not everything needs to be learned. So like you can get a lot of work done without having a ton of knowledge. You can get good work done, and you can you feel really productive and actually like make people's lives better by building them tools that solve problems for them. And you can do that without being an expert. And I think that's something that's kind of cool about computing.
Yeah.
I think more people need to hear that, because I know in my experience it took me more than 5 years to learn that, to accept that fact. Because that's very hard. You need to let go of your ego and just accept, okay, I don't know this. And it's okay to not know.
I'm being outsmarted by a pile of rocks with electricity going through it. I just had to accept it. Well, I was walking around the house the other day going meaningless, but my brain's going, kind of ecclesiastical, going meaningless, everything's meaningless. Why am I writing code? What is the point? And I'm like, why am I even in this spot? And I brought it up to my mother, and she's like, well, the thing is, it's not about the code. It's about you're giving people the tools to do what they need to do. I'm like, okay, well, that works. That gives me meaning and purpose again. Thank you.
She's awesome.
Yeah, she is.
Yeah, like what's more important, the paint or the painting?
Yeah, exactly.
Depends on who you ask, right? Like it's
So we we always like to ask too, wrapping up here a bit, but what is the weirdest bug you've ever encountered?
So I think the weirdest one is one that I encountered recently, and it wasn't in something that I built, which I think made the investigation even more fun. But it was a product that I'm using from a company that helps it helps you keep track of like a small business's inventory of computers and like whether or not they're up to date, whether or not encryption's turned on, things like that. So, and that's something that my company was reaching the size where like knowing the answer to that started to become something that I was worrying about. Like, does everybody have their hard drive encrypted? Are people keeping their systems up to date? Because that was the kind of thing that we were starting to be asked. Like, do you enforce this? Do you monitor this? And so I'm like, well, maybe we should start. So found this product to help with that, and I'm not going to name names because I don't want to pick on anybody. But I had it installed, and I had been using the Mac OS version and hadn't really had any trouble with it. And so I was giving the Windows version a try. And I kept noticing that on the computer that I installed, the Windows computer that I installed it on, one of my processors was always pegged at 100%. And I couldn't figure out why. And I always felt like I didn't have time to investigate it. And it just did, like, the fans were always running, like the battery life was really poor. But I was just, really confused. And so I started trying to figure out okay, what's causing this? What is running that's consuming that much processing power? And so I found the process that was doing it, and it was like a PowerShell script. And so went and saw that it was a PowerShell executable. So then I'm like, well, what is that running? So then I had to figure out how to see the full command that was executed. So I looked up how to do that and was able to see like the exact file that was running and the parameters that were passed into it. And so then I could open up another terminal window. I could open up a terminal window and I could copy and paste that and like just observe it, just sit there and hang and not do anything. And so then I open up the file to take a peek at that script and discover that it's part of this tool that I installed to help me keep track of like, you know, whether or not the computers are up to date. And then I read through the script and it's really short. It's like 20 lines long. It's not really doing much. But one of the things it's doing is it's running a command to get the list of updates that have been installed from the Windows Update like engine inside of Windows. And nothing looked like it would crash or take forever. And so I started running those lines one at a time, and found the one that was hanging, and it was one of these commands. And so I was like, where did this script come from? This thing that's being executed, where does it come from? And so I thought maybe it was something that the company that built this tool wrote. And so I started looking for the source for that on my computer and didn't find it. And so I had to go look on the internet and found that it's from a third-party library that you can install inside of PowerShell. They have like kind of like packages or modules that you have for other languages. So like if you're working in Python, you can say like pip install. PowerShell has something similar where people can publish modules that you can install and then execute. And so this particular function was coming from a third-party module, and it was like the second most popular module on the package system for the PowerShell that was being used. So I tried to go find the source code for it, but this source code isn't published anywhere that I could find. And I was like, well, I want to know what it's doing. So then I attached my debugger to the process, and then just stopped the process, and then trying to find the thread where it was hung to try to see like what's going on. And I finally was then able to like disassemble enough of the code that's being executed to see the C# logic that it was following. And there was a loop that was checking to see if something equaled if something equaled 0, but like looking at the logic, like this can never equal 0. But like I don't know how to fix it because like I don't have the code and I didn't write this system, and so I was like, well, I wonder if there's a way to work around it. And then I read through the rest of the code and I see like if you pass in a parameter, it goes down a slightly different code path. And if you use that code path instead, you don't get stuck in an infinite loop. So then I tried it out on the terminal and like added that extra parameter, and like sure enough, it finishes right away. So then I was able to contact the company that produced that utility and say, hey, you've got this problem. Here's a workaround. Here's how to detect it. Because they had some like telemetry statements. So they had there's like 2 major operations that were happening in that file, and each one had a telemetry command to record that it had happened. So I said, you should be able to detect how many of your customers are affected by looking for places where you see this telemetry data point, but you don't see a corresponding other telemetry data point, because they should both happen pretty quickly after each other. Yeah, that was a lot of fun. So I figured out the workaround, and then I tried to reach out to the developer of the package, but I haven't heard anything yet. Kind of offered to help, and then asked if there was a place where the source code was available so that I could dive in and try to work up a patch. But yeah, so like that was probably the weirdest one that I've encountered.
Guerrilla debugging.
It was a lot of fun.
That sounds like a blast. Well, Scott, it was great to have this conversation with you over coffee for me, soda for you.
Yeah, good soda.
Absolutely, it was fun. Bojan, are you still there?
Of course I am. I was just enchanted by the story. It's so amazing. Like, I'm trying to follow all the threads, and I'm like, man, this person is brilliant. Like,
thank you. That's really kind.
And that's definitely saying a lot coming from Bojan, because he's gotten to the point where he's no longer mesmerized by the unicorn in the corner over there. So, Scott, if there's any menders out there that want to, find more of their people, where should they go?
Yeah, so my favorite place to send people who think they're menders and want to find other menders is an online community that Andre and I created called legacycode.rocks. And you can hang out there. There's a Slack community and a podcast and sometimes occasional newsletter. And then we ran a conference last year called MenderCon, and we're in the planning stages for doing a 2021 version of MenderCon as well.
That's fantastic. Well, it was great chatting with you, and hopefully you'll be able to find the portal out of here because things have been a bit weird around here today.
Yeah, it spits me out underneath my desk, but that's okay.
Oh, okay. All right. Well, I mean, I suppose there are worse places to come out.
That's right.
Well, it was a real pleasure having you.
Likewise. Thanks, Bojan. Thanks, Jason.
Thank you.
Bug Hunters Café. This is Marta. Yes, we are located online at bughunters.cafe and on Twitter and Dev as Bug Hunters Café. Online, the internet, it's well, where are you calling from? Today it's more like, when are you calling from? Oh, and how is the weather in Delphi? Sounds lovely. Oh, that music is provided by audionautics.com. We have the link on our web. Never mind. You're very welcome. Hope to see you soon. I didn't think ancient Delphi had phones.
Maybe support was added in a later version.
I don't think we are talking about the same Delphi.
Delphi, as in the Oracle of...
I could have sworn it was invented by Borland, not Oracle.
Go away.